Okay, in this video we're going to talk about a Bronsted base, so that is a weak base, a species that accepts a proton and sets up a dynamic equilibrium with water. A lot of times this is the conjugate acid for a weak base, and when we talk about a Bronsted base, we have a general, we can generally just write it as a B. Okay, so let's make this as a B plus H2O. So it's going to accept a proton from water. So it's an opposite to a weak acid, and it's going to go and be an HB plus OH minus. Okay, so this is an equilibrium for a weak base. Now, because we have this equilibrium, we can also set up or write an expression. But when we write the expression, we remember we leave off the water just as we did with a weak acid. So we end up getting a weak base expression, that is a Kb expression, equals the HB. Okay, so this is our conjugate base. So conjugate acid of a weak base, or hydroxide concentration over the concentration of our weak base. And we can go through the same simplifying that we did with weak acid. We can say, hey, look, because we know that every time the weak base reacts with water, it produces the conjugate acid and the hydroxide, that those concentrations are equal. Okay, and then because we know that, we then can simplify and then we can rearrange. So we can simplify, we can go Kb equals OH minus squared over B. And if I want to find the concentration of OH minus, it's exactly the same as the concentration of H3O plus and how we rearrange it. It becomes the square root of the Kb times the concentration of the weak base. Okay, so one thing to notice here is this hydroxide ion concentration, okay, has a relationship with the H3O plus or the hydronium ion concentration. That's OH minus concentration times H3O plus concentration equals 1 times 10 to negative 14. And this value is called Kw, or this expression. There's also an interesting, because of this, we can say that the negative log of this, which is POH, plus the negative log of H3O plus, which is pH, equals 14. Now this is really important because we can use this expression to make some of our calculations a lot simpler. So look, before we can start, we need a value of Kb. And the value of Kb is never given because we're always given a value of Ka. Now the value of Kb is very interesting because it's kind of just like the OH minus. And the way it's like OH minus is the following. We can, the Kb times the Ka equals 1 times 10 to the negative 14. Okay, so those two values multiplied together to equal 1 times 10 to the negative 14, just as OH minus and H3O plus 2. And also the negative log of them, which is the pKb times the pKa equals 14. Now this is a really an interesting relationship, because we'll use that to simplify things later. Look, there's two ways that if someone gives us the Ka of something, but I need to work out, we can see, look, I just want you to look at this here. See this ammonia here, NH3, but then they give us the Ka for its conjugate acid. So this is a Ka value, so this must be a weak acid. And because this is a weak acid, it means this thing here must be a weak base. Now what that means is because they want to find out what the pH of a weak base is, we know that we're going to have to do a weak base expression, and we can't use the Ka value, so we've got to turn it into a Ka. Now how do we turn a Kb value into Ka? We rearrange this expression here, and we divide 1 times 10 to the negative 14 by 5.75 times 10 to the negative 10, which is the Ka. And the value that that gives us, let me just put this into my calculator, if I can turn it on. Okay, so we have 1 exponential negative 14 divide 5.75 exponential negative 10 equals 1.74 times 10 to the negative 4. So I'm going to put this into my expression, and I'm going to find out here what my concentration of OH minus is. Okay, that equals the, remember that, the square root of the Kb, 1.74 times 10 to the negative 4, times the concentration, 0.01, equals 1.74 times 10 to the negative 6. Now, interestingly, we can turn this concentration of OH into something that's called a POH. Now, what is a POH, you ask me? POH is just the negative log of OH minus, or hydroxide ion. So if I do the negative log of this answer, now let me just do this on our calculator. So I want to do the negative log, delete the log of answer execute is 6.76. That's my POH. But you know, they didn't want to know what the POH is. 6.76 is the POH. They wanted to know what the pH was. But remember, go up to this expression that I said all the way up here. Now I'm going to rewrite it again instead of just scrolling all the way up to the top. Okay, so and the expression was this: the pH plus the POH equals 14. So if I know if I want to know the pH, it equals 14 minus the POH. This is so I don't have to turn everything back to concentrations to rearrange it. So I go the pH equals 14 minus 6.76. Now we just do this in our head, right? And we can get, oh, well, that's 7.24. And we don't have to go through the bother of putting in the calculator because of this expression of the pH and the POH. Okay, so, oh, look, I had all that working down here. So this is how we might do it if we wanted to work it out longhand. I'm not going to go through that, but I am interested as to why they got a different answer. Let's have a look here. What have we done? We changed that to that. We found out the concentration of OH minus, 1 times 10 to the negative 6. My goodness, there's our problem. Okay, so let's fix this up now. Problem is this. Cross. Can you see what the problem is? The problem is I forgot to square root. So let's do this again. 1.74 exponential negative 4 times 0.01 equals. Now let's do the square root of that. Shift answer equals 1.31. Yeah, so this answer here is 1.32, sorry. 1.32 times 10 to the negative 3 moles per litre And I'm just going to turn this into pOH. So I'm going to do the log of this, or the log, or the negative log of that. So negative log, we've got 1.32 exponential negative 3. Okay, I'm just going to go through and log that. And it gives me 2.88. So my pOH here is 2.88. And therefore my pH is 14 minus 2.88. And that gives me 11.12. And hopefully that's the same as the answer I had down the 11.12. What have we done wrong here again? Okay, let's just disregard the stuff I've put at the bottom, because I'm pretty sure that these are the wrong answers here. Okay, so you can go through and try and do that yourself, check whether you agree with the same with me. Look, and then practice these ones here as I just did it above. I'll give you the answers for these ones, and you can check them once you've done them. Don't forget to pause it now before I put the answers up. Okay, and so now for the answers to these problems. So the first one, when we go through the calculations, we get the concentration of the OH minus is equal to 2.95 times 10 to the negative 3. Now this gives us a pOH of 2.53. Now be careful, this is not the answer, because remember we need the pH, which is 14 minus this number, which is 1. Sorry, there should just be a dot there, 1.47. Sorry, 11.47. Okay, so the next one is an interesting case. So when we multiply these together, so when we find the pKb of this, and we multiply it by this, and we do the square root, we get a number here of 2.51 times 10 to the negative 8. Now, if you bear with me here, if you take this number, this is the moles per litre of OH minus. Now, if we actually find the pOH of this, we get the number of 7.6. Okay, this is the pOH. That would mean that the pH would be 6.4. And this is a weak base. And you say, well, how can I have a pH? There's an acid. Well, actually, you can't. And this is where this breaks down. You remember we said before that when the weak base reacts with water, it breaks equally into the conjugate acid and OH minus. Well, in this case, that is true, and this is how much of the OH minus is produced from that. But we can also assume that we had in the solution 1 times 10 to the negative 7 moles per litre of OH minus for a start. Okay, or H in the solution originally, the OH minus equals that. So when I add the concentration of what we have from our very weak base onto our original concentration, I now get a concentration of OH minus that is 1.25 times 10 to the negative 7 moles per litre. Okay, this is because we hadn't accounted for the hydroxide that was already in the water. So we get that concentration, we multiply these two up, and we get an answer of, we get a pOH now of 6.90, which is fine because it gives us a pH of 7.1. It is a base, but a very weak base. Okay, so finally the answer here, I'm running out of my 15 minutes, 0.0303 moles per litre. That's the concentration of the OH minus. pOH equals 1.52. So my pH equals 12.48. Thank you for listening.